In this section, we'll be exploring quadratic graphs. The three forms of a quadratic are shown here. Standard form, which is what you're most comfortable with, is y equals ax squared plus bx plus c. Factored form is y equals a times x minus r1 times x minus r2, where r1 and r2 represent the two x-intercepts, or the roots of an equation. The reason why it's called r is for roots, which is another word for x-intercepts. In vertex form, we have y minus k equals a times x minus h squared. I want you to realize that really this form is just like the trig functions from last year. When you graph sine, say for example, sine of x minus pi, this adds pi and moves it to the right, while this h moves this h to the right, making the vertex at h comma k. Just like in the sine graph, if you add this over and have like a plus 1 at the end, this would move it up or down, and therefore this is what would affect the raising or falling of the vertex. So in reality, this is simply an adjustment of the translations from chapter 4 of last year. Each form has their perk, so we're going to explore one of each type in order to see whether or not, or what the perks are of each type. The first problem that we'll do is in standard form. Y equals 2x squared minus 8x plus 5. On this equation, first thing we're going to do is find the x-intercepts. To find the x-intercepts, we let the y value equal 0. So we have 2x squared minus 8x plus 5 equal to 0. Now this you could try factoring, but factoring will not work. This is a quadratic formula problem. When we use the quadratic formula, we get 8 plus or minus the square root of 64 minus 4 times 2 times 5, all over 4. When we simplify this, we get 8 plus or minus the square root of 24 over 4, which then becomes 8 plus or minus 2 to the root of 6 over 4, or 4 plus or minus the root of 6 over 2. Since I don't have a calculator on me, I can approximate this by 4 plus the root of 6 is between the root of 9 and the root of 4. Therefore, it's around 2.5-ish. So 4 plus 2.5 is around 6.5, divided by 2 is probably around 3.25-ish, is a good estimate. And if I take the other version, 4 minus 2.5, we get 1.5 divided by 2, which is 0.75-ish. So those are x-intercepts. Now let's find the y-intercept. The y-intercept, we let x equal to 0 now. So y equals 0 minus 0 plus 5, so y equals 5. Notice, this is what's easier in standard form. Standard form always gives us the y-intercept. The last part is the vertex. The vertex we can find by using the formula x equals negative b over 2a. If we plug in negative b, we get 8 over 4, which is 2. We can then plug that in for the y value and get a value of negative 3. Therefore, we can now graph this. These are the three characteristics of every parabola that I want to see. I want to see the vertex, the x-intercept, and the y-intercept. So the vertex is at 2, negative 3. The y-intercept is at 5. And the x-intercept, as we said, is around 3, and a little more than 3, and about a little less than 1. And you can see that lines up perfectly to form an upward pointing parabola, which makes sense because the a value is positive, which makes the parabola point upward. So standard form gives us the y-intercept as a c value in the formula, which is its perk. Number 2. Y equals 4 times x plus 1 squared minus 1. Notice again, this does not quite line up with vertex form that was shown above. You can see up here I had k on the other side. I wrote it like this because in the end I think this actually makes more sense for you guys. Going back to last year, this moves to the left 1, down 1. Therefore the vertex is -1, -1. So again, that relates back to chapter 4 from last year. So vertex form, the perk of vertex form is that you can just see the vertex right away and grab it and be done with that one. So now let's find the x-intercepts. The x-intercepts, we let y equal 0. So you can see this equation is going to be a lot like solving and completing a square type equation. We add the 1, divide by the 4, so we get 1/4 equals x plus 1 squared. We take the square root, we get 1/2, don't forget your plus or minus. So we can then subtract the 1. -1 plus 1/2 is -1/2. A -1 minus 1/2. -1 minus 1/2 is -3/2. So we have the vertex, the x-intercept. Now let's find the y-intercept. The y-intercept, with that x equals 0. So y equals 4 times 1 squared minus 1, which is 3. So let's draw our graph. The vertex is -1, -1. The x-intercept is -1/2 and 3/2. And the y-intercept is 1, 2, 3. Yeah. Again, it's pointing up because the a value is positive. By the way, we could convert this to standard form very easily by FOILing this out, distributing. And in class, when you guys come back, return to school, we will actually convert standard form in problem number 1 to vertex form using the completing a square in the last unit. The last problem I would like to do is factored form. So let's take the following problem in factored form. In most of your algebra courses, you spend most of your time on standard form. Vertex form is going to become very big because of the completing a square process, where we will use that in conic sections later on in chapter 11 and chapter 6 as well, in order to complete the square, in order to find the formula for circles, ellipses, hyperbolas, and so forth. Factored form is also very useful, and we use it throughout the year. The perk of factored form is we can see the x-intercepts just by looking at it. And though this is obvious in a quadratic, we will spend more time looking at any polynomial function, where a polynomial function is anything of any exponent of x, so x to the 4th, x cubed, x to the 5th, whatever. So that's the beauty of factoring. If you can factor something, you can see all its x-intercepts. So now, here's the problem. Let's find the x-intercept. The x-intercept, we let y equals 0. If you let that equal 0, that's the perk of this form. X equals -4 and 3/2. Just by looking at it, you can tell. The y-intercept is also very easily calculated. If you plug in x as 0, you get y equals 4 times -3, which is -12. So you can find both intercepts very easily. The last thing is the vertex. The vertex, we have to work a little bit harder. We're going to have to FOIL it out and convert it to standard form. So we get 2x squared minus 3x plus 8x minus 12. So we have 2x squared plus 5x minus 12. Real quickly, you can see that the minus 12 there agrees with the y-intercept, so they do match. So now let's find the vertex. It's -b over 2a. So the x value is -5/4, which is lovely. We then plug this back in to get the y value. So negative 5/4 plus 4 times 2 times negative 5/4 minus 3. This here is 16 over 4, so it's 11/4, times over here we have negative 10/4 minus, I'll scribble it up here, negative 10/4, which reduces to negative 5/2, minus 3, so that would be negative 11/2. If we multiply them together to get the y value is negative 121 over 8, which is approximately somewhere in the 13-14 range in the negatives. So let's graph this. We have a y-intercept of negative 12. We have an x-intercept of negative 4 and 3/2. And the vertex is negative 5/4, and again it's somewhere down here on 13-14 range. And there's our graph. So again, you learned 3 different forms in this unit. The 3 forms being standard, factored, and vertex. They all give us something that is beneficial. The factored form gives us the x-intercept as shown here. The vertex form gives us the vertex, and standard form gives us the y-intercept. And one of my main focus this year will be more on the factored form and the vertex form, since it will relate to later things later on in the year. So with this, you should be able to do section 7 from the summer assignment.